Hi guys! In the previous lecture we have talked about Ohm's law and power law and we have become familiar with it. So from Ohm's law we know that the relation between the current and the resistor is inversely proportional. Yeah, in this lecture we apply Ohm's law in both connections, series and parallel. The main feature for series connection is that the passing current will be the same in all circuit, but the voltage will be divided across the loads. Please note that any electric device, any electronic device, any equipment has its own resistance value, such as AC, boiler, frigidaire, and so on. Of course, you can add more resistivity to such equipment, especially when you work or designing an electronic board. Okay, let's look here in this question. Determine the value for the current and the voltage across R1 and R2. Well, let's mention the given first. R1 is equal 18 ohm, R2 is equal 26 ohm, and the main voltage of the main source is 220 volts. Yeah, we are requested to obtain the current and the voltage across R1 and R2, V1 and V2. In order to get the value of V1 and V2, you must calculate first the value of current. Why? Because the current is the same in both loads since we are in series connection. So when we get the value of the current by applying, of course, Ohm's law, we can get V1 and V2. I mean the voltage across R1 and R2. Yeah, so let's solve this question. First, make summation for the resistors to get R total. So our total is equal R1 plus R2, which is 44 ohm. Now, by applying Ohm's law, you can determine the value of the current, which is I is equal V over R, 220 volts over 44. The final answer is 5 ampere. Now, just go back to the first circuit and calculate the voltage across each load. Therefore, V1 is equal R1 times I, which is 90 volts. V2 is equal R2 times I, which is 130 volts. To ensure that your results are correct, V1 plus V2 must be equal to the main source, which is 220 volts. Conclusion. In the series connection, the passing current will be the same in the whole circuit, while the voltage will be divided across the loads. Also, the high resistor has the high voltage and vice versa. Again, the high resistor has the high voltage and vice versa. And you can observe that from V2. V2 is equal 130 volts. It's bigger than V1 because R2 is bigger than R1. Now, parallel connection. Parallel connection is the opposite of series connection. It works in different way. The main feature here is that the passing current will be divided across the loads. However, the voltage will be the same across the loads. Okay, the question is to determine the value of I1 and I2. The given values are R1 equal 10 ohm, R2 equal 5 ohm, while V1 equal V2 equal the main voltage source, which is 220 volts. Yeah, we can apply Ohm's law immediately. I1 is equal V over R1, which is 220 volt over 10. The answer is 22 ampere. I2 is equal 222 over 5. The answer is 44 ampere. As you can see, a direct application, nothing complicated. Please note that if you want to calculate the total resistors in parallel connection, you have to follow this rule. Number one, you make like the inverse. 1 over R total is equal 1 over R1 plus 1 over R2. The answer is 0.3. Now take the inverse for this result. So R total will become 1 over 0.3. The answer is 3.33 ohm. Now you can calculate the total current, which is I total is equal V over R total. The answer is 66 ampere, approximately the same as the previous one. We conclude that in parallel connection, the current will be divided across the loads, while the voltage will be the same across the loads. Also, the low resistor, the high current, and vice versa. Please note that in our houses, offices, and mall, we use parallel connection in order to keep the voltage same across the loads. Okay, good luck. See you in the next lecture. Bye bye.